Hello, I'm Sergio Alvarez, and I am here to tell you a little bit about a project that I'm leading related to the social and economic impacts of Florida red tide. Before I continue, I would like to acknowledge the agency that is funding our project, the Gulf of Mexico Coastal Ocean Observing System, GCOS, as well as my other team members. So besides myself, at the University of Central Florida, I am trained as an economist. We have Heather O'Leary, who is trained as an anthropologist, and she's at the University of South Florida. We have Frida Baja, who is a PhD candidate in the hospitality management program here at UCF. And we have Christina Brown, who is trained as an economist and was working as a postdoc over the last 2 years here at UCF. So our project is focused on the 2018 harmful algae bloom event of red tide here in Florida. One of the interesting things about this year, 2018, was that it was one of the perhaps stranger years in which red tide is really spread out throughout the different counties in Florida. Usually it occurs mostly in Southwest Florida, so mostly in Sarasota or centered around Sarasota County, which is this orange bar to the very left. And so most of the counties that are getting the red tide usually are located down there in Southwest Florida. In 2018, we really had the blooms in Southwest Florida, but we had them in the Florida Panhandle as well. And the currents took the red tide all the way around the Keys and up the east coast of Florida. So we experienced it in places like Daytona Beach, Miami, Fort Lauderdale, and the like. So I was telling you that we are looking at the social and economic impacts of red tide. So what do I mean by social and economic impacts? So our, say our primary target sector or target discipline in this grant is economics. And we are very interested in what happens to the tourism economy when there is a harmful algae bloom. So we know that the tourism economy is dependent and heavily linked to the destination image of the particular destination, the particular coastal area, and how that also has a bearing on tourist choices, whether people decide to come to visit this tourism destination or not. At the same time, we also know that communication discourse is very important in how we form this destination image. And it also has an impact on people's choices whether to visit a place or not for their vacation. So we also wanted to look at discourse surrounding the harmful algae blooms, particularly social media discourse. So the way we are sort of conceptualizing this is that there's multiple discourse communities. People don't talk to everybody or don't listen to everybody. You know, we listen to certain people or certain organizations more than others. We also, some groups talk one way, they speak one way, some groups speak in a different way. So we wanted to look at how that communication, that discourse was impacting people's norms, behaviors, choices, and preferences, which at the same time have or define what happens in the tourism economy. So this is our conceptualization of the system. So down here we have the ocean, of course, and this is a coastal destination. So what we are interested in is essentially what happens when there is a bloom over a tide, how the economy is impacted, how the destination's image is impacted, how people talk about the blooms, and we also want to see if we can relate relate those things to one another. Some of the guiding research questions behind the project include, we really want to know the dollars and the cents in terms of the economic impact. How much is the economy on average losing when there's a harmful algae bloom of Florida red tide, of Karenia brevis? We also want to test if there is a difference between, say, indicators or signals that we can extract from the material world, right? The water sampling, and the signals that we could extract from something that is more socially constructed, such as the Twitter discourse, the type of posts and the number of posts about red tide in a given time period. We want to compare which one better predicts the changes that we see in the marketplace. Finally, we want to identify among this HAB discourse, which types of discourse, what type of content would amplify or attenuate the economic impacts of the harmful algae blooms. Our methodology is a little convoluted, but I'm putting this figure together to try to explain to you. So on the blue things are secondary data sets. The yellow is a project generated data set. It's something that we are creating through this project. And then the purple arrows are analytical techniques or methods that we are using to transform or maybe to analyze certain data sets. So one of our initial data sets is this water sampling data from the Florida Fish and Wildlife Conservation Commission. They run a very robust surveillance program. So we have requested all their data starting in 2002, and they have sent us the data. So we have all of that. We are also looking at the historical Twitter database, and we scrubbed it to essentially identify any tweet related to the harmful algae that came from Florida or that we could verify was legitimately related to Florida in the years 2017, 2018, 2019. So the first thing we do is the samples, we transform those samples. Those samples, they give us essentially one reading from one particular water sample, and it has a date and a location. So we use those all those samples to create an indicator of the number of days in which red tide impacts a particular county. The Twitter discourse, we run it through a topic analysis, and we identify the different topics that people are discussing in social media related to the harmful algae. And we monitor those topics over time. So we are using that as essentially as an indicator as a subjective indicator of the red tide. We are essentially joining or integrating these new data sets into an existing panel database, economic data panel database that we have constructed using data by published by the Florida Department of Revenue. So it's monthly data for each county. So we have 67 counties, one observation per month, starting in 2002 or 2003, I believe. So we combine that, we can do an econometric analysis that tells us or gives us an estimate of the loss in tourism revenue, because we're looking at the tourism economy particularly. And we can also do a qualitative content analysis that characterizes or tells us a little bit about what is happening in social media related to the harmful algae. So to give you a little taste of what the data looks like, this is the tourism sales from all the state of Florida. To tell you a little bit about the seasonality of Florida tourism. So the peak of the tourism season here in Florida is around spring break. It's around April. That's when the, basically the tourism spending is at its highest. Then as it starts getting warm, the tourism ebbs a little. A lot of us really love the heat of Florida, but a lot of people from up north, they don't. So they essentially go back. And then towards the end of the year, when the weather starts cooling down here and getting really glorious, people start coming back. Over the years, there's been a notorious increase in tourism spending. Obviously, what we have seen with COVID changes that story quite drastically. But even post-COVID or during COVID, we've seen a significant recovery in tourism here in the state of Florida. These are just the descriptive statistics of the econometric model that we're running. So in essence, as I was telling you, we have transformed the samples, the water samples, into this measure of how many days in each month the county experienced red tide at different concentration levels. These are average concentration levels. So the whole average for that particular day, if it was greater than 1, but less than 1,000, it would be marked in this category. And if it was if the average concentration of all the samples taken in that day for that particular county were between 1,000 cells per liter and 5,000 cells per liter, the county would be identified, or that particular time period would be identified here. And so we built these types of indicators for different categories. And so the idea was to identify at what intensity of the bloom do we start seeing these negative economic impacts. And interestingly, what we find is that on average, the average concentration of all, when you take the average of all the samples taken in a day, when it's higher than 5,000 cells per liter, this is when you start seeing your negative economic impacts. Our model is, we sort of scale the data so that we could recover parameters that imply millions of dollars. So in this case, what our model is, the way to interpret the results of this model is that one additional day of Karenia blooms will reduce that month's tourism-related sales by 1.55 million. So each day is costing the tourism economy on average 1.55 million each day of red tide. To tell you a little bit more about the discourse database, they have discourse database. So it was built using Twitter's search API. We looked for everything related to harmful algae blooms, to red tide, to HABs. We only considered original tweets, no retweets, again, from 2017 to 2019. We wanted to make sure that these tweets were legitimately from Florida, that we weren't getting things from Lake Erie or anywhere else. So we were relying on tweets that were geotagged or where the profile of the person who posted the tweet, whether that profile was geotagged, and those geotags were inside of the state of Florida. We also used that geotagging to essentially assign tweets to particular counties. So we did that first scrubbing. We got about 5,500 tweets. We started reading through them, and there were a bunch of things in there that didn't seem to be about the algae blooms. They didn't seem to be related to the algae blooms. So we did a second cleaning, a cleaning process where we used redundant manual labeling to annotate a subsample of these tweets. So we essentially went by hand, and we identified several of us, read the tweets and identified whether they were relevant to harmful algae or not. And we used that process then to train a computer to essentially do this for the rest of the sample. So at the end of the day, we ended up with almost 4,000 tweets, 3,936 tweets. Our you know, as I mentioned, we did a topic model. We actually tried several models with different numbers of topics. And we landed on this one with 10 topics because it seemed to make the most sense. Interestingly, there's 10 topics. As you can read the topic titles here on the left, this is what they call an alluvial chart. It shows you where some of these words are ending up in the different topics. Interestingly, 10 topics, you know, sort of what you expect: red tide, toxic algae blooms, Florida, hashtag red tide, Florida, dead fish, beach, water. You know, one thing that really we found interesting is how politicized the discourse is. So Rick Scott, who is now a senator and used to be the governor at the time of the 2018 algae blooms, he appears in this content all throughout, except for one topic. There's only one topic where there isn't a significant presence of politics or partisanship, and it's the one about dead fish. Some of the types of partisanship or polarization related discourse that we found are things that attribute the hub to a particular entity, mostly Rick Scott. Rick Scott becomes a symbol of red tide in the discourse, in the hub discourse on Twitter. There's also a lot of references to the blue wave and how red tide is fighting the blue wave, or blue wave is fighting the red tide. The media is present in multiple roles. Sometimes they are, you know, some of the people writing are tagging the media to, you know, for a particular opinion, or to look more into a particular event related to the hubs or a particular supposed source. You know, the 2018 election cycle happened right in the middle of all this. So that may be something that is confounding somehow our findings. And we also found a lot of pseudoscience or scientific misperceptions, strange explanations for the algae blooms. So I also mentioned that we were using the, you know, because we have the dates of the tweets and we know what, essentially what topics are covered in the tweet, we can monitor how each particular topic occurs through time. You know, if the topic reaches higher levels of discussion, if there's more tweets in that particular topic over time, then you see these high readings. So you would assume that if people are talking more about the red tide, is because there's more red tide out there. So in essence, these coefficients, they vary in value from 0 to 1. As I said, they are all aggregated across months. And this is what we are trying to use as the indicator. So let me just show you what this looks like in contrast to the water sampling. So this is what we constructed from the water sampling. It's telling us the maximum reading in a particular county for that particular month. So in this case, we are saying that this could be used as an objective indicator of the hubs, or, you know, based on empirical findings from water samples. And this is what the discourse looks. Unfortunately, our sampling is cut at the end of 2019. We have not integrated the 2019, I'm sorry, at the end of 2018. We have not integrated 2019 water sampling data, but we will. But this is what it looks like for now. So there is this spike essentially around the summer that you see where the red tide was occurring, and where the bloom was getting really intense, and discourse was also getting really intense. So just to summarize the results, the negative economic impacts of the Karenia blooms start occurring whenever the average concentrations exceed 5,000 cells per liter, according to our model. the interpretation of the model is that one additional day of Karenia blooms reduces a month's tourism sales by 1.55 million. So each day of red tide on average costs $1.55 million. They have discourse analysis, and one glaring finding is that it is very polarized. There's a lot of negativity and just blaming certain parties for the algae blooms, and that is something that we observed. And that finally, that more work is needed to really say if with good indicators, reliable indicators of harmful algae using social media data. Thank you so much.